Hello students, welcome back to the next module of the chapter, oscillatory motion. In this module, we'll study three important terms. The first, we'll study the remaining terminologies of oscillatory motion. We'll see what is harmonic motion, and we'll see very special type of harmonic motion that is called as simple harmonic motion. So to begin with, let's complete the remaining terminologies of oscillatory motion. Students, in the last module, we have already learned 5 terms related to oscillatory motion. First one was mean position. Next, we learned what are extreme positions. We learned displacement, amplitude, and path length. So 5 terms we had already completed. We'll move on to the 6th term, that is nothing but period, represented by capital T. It is also called as periodic time. Now, before I define it, period or periodic time are the terms normally used in physics whenever a motion is periodic. Since oscillatory motion is a periodic motion, hence we have the term period attached with oscillatory motion. Before I define period, let's have a look at what is exactly one oscillation equal to. So let's understand through this diagram. Observe the motion of the block clearly. So we can see the block is moving, and as we saw initially, the block was at mean position. It goes from mean to right extreme to mean position, mean to left extreme, and from left extreme it is back to its initial position, that is mean position. Whenever a particle comes back to its initial position with same direction of motion, it is said to complete one oscillation, and the time taken to complete one oscillation is nothing but called as time period or periodic time. So I can define period as the time taken by a particle performing oscillatory motion to complete one oscillation is called as period of oscillation. Formula: so capital T time period is equal to 2 pi by omega. Formula remains the same as in circular motion. The units: SI unit will be second since it's time. CGS unit also remains the same, seconds. And dimensions being time, it will be m raised to 0, L raised to 0, T raised to 1. Let's see the next term, students. Frequency. Definition is similar to that of circular motion, except there we used to use the word revolution. Here it will be replaced by oscillation. So frequency can be defined as the number of oscillation of a particle performing oscillatory motion in 1 second is called as frequency. In 1 second, how much oscillations it has completed, that number is called as frequency, represented generally by small n. Formula, as we know, it is reciprocal of time period, so n is equal to 1 upon t. And units, reciprocal of time period, 1 upon second is called as hertz, hence SI unit is hertz. CGS unit also remains the same, so it is hertz. And dimensions will be reciprocal of time period, hence m raised to 0, L raised to 0, T raised to minus 1. So these were the 7 terminologies that we will be frequently using in this chapter. Let's move on to the next part, and that is nothing but harmonic motions. So what are harmonic motions? Let us understand through a small example. Block attached to a spring, and we know it is a spring mark system. Now in this case, as we know the spring vibrates, the displacement goes on changing with time. Suppose I plot a graph of displacement of this particle versus time, we will find that this displacement versus time graph is a sinusoidal curve, or it is a sine curve. So as we see, whenever a particle performs a to and fro motion, the graph of displacement of the particle versus time is a sinusoidal graph or a sine curve. So what are harmonic motions? So we can define as the periodic to and fro motion. So here the block is performing periodic to and fro motion, yes. So the periodic to and fro motion in which the value of displacement, velocity and acceleration are expressed as a function of sine or cosine. Here it was sine, it can be a cosine curve also. Then those motions are called as harmonic motions. So to generalize, periodic to and fro motion, wherever the displacement curve or velocity or acceleration can be expressed as a function of sine or cosine, such functions are called as harmonic functions. Now today in our syllabus we will study the most simplest type of harmonic motion, which is called as simple harmonic motion, and it is abbreviated as SHM also. Now before we go on, what is exactly simple harmonic motion? Let's see the classification. So it is classified into two types. The first, it is called as linear SHM. When is the motion called as linear SHM? Yes, the word linear reminds of something called as straight line. Yes, we are right. So if the SHM takes place along a straight line path, then it is called as linear SHM. As in this example, the block performs to and fro motion, but the path is a straight line. So this is an example of linear SHM. And the second type is angular SHM. Now if linear SHM is straight line path, then obviously angular SHM will be some curved path. Say, take an example here. The needle in a magnetic box, as you can see, it is to and fro motion, but the path is a curved path. So we studied what is harmonic motion, and we have just introduced the word simple harmonic motion in this module. That's all in this module, students. See you in the next module.